So now we are tackling example 5 still, but moving on to part B. Now this one is going to be basically exactly what we did in the problem up here. So I encourage you, if you think that you understood part A, I would try this one on your own and go ahead and fast forward to the end of the video and see if you got the right answer. But I will go over, just like I did before, how we graph this lovely piecewise function and find the domain and range, which is also a blast. So for this very first one, again, what I like to do first is figure out where the lines on our graph go, so we know exactly where each part of our piecewise function is allowed to be graphed. So in this one, we only have one number, which is a 2. So that means I'm only going to be drawing one line, and we're drawing a vertical line that intersects the x-axis at 2. So it must cross the 2 on the x-axis. So I'm going to draw my dashed line so I know where the graph can and cannot go, which section of the graph it is allowed on. Okay, so one of our pieces of the piecewise function will be allowed on the left-hand side of the graph, and one of the pieces of the piecewise function will be allowed on the right-hand side of the graph. So let's see which one goes where. Okay, so let's look at this purplish pink graph. I'll just call it pink. Let's see where this one is going to go. So if you look here, okay, this one is allowed where x is less than 2. So if you're looking at the graph, okay, the values where x is less than 2 are on the left-hand side of the graph, because we have like 1 and 0 and -1, -2, -3, and etc. So this first half, the left-hand side, is where our very first graph will be allowed to be graphed. So let's go ahead and graph that function. So remember, when you make a table, we like to pick 3 values. It gives kind of a nice shape for the graph so we know what it will look like. So on this first part, we're going to start with the number in our inequality, which is a 2. And then I'm going to pick 2 other numbers that are less than 2. So it doesn't really matter what you pick. I'm just going to pick I don't know, 0. 0 is always easy. If you can ever pick 0 in your table, it's always an easy number to check because 0 is really easy to work with. And I'm just going to pick -2. Why not? Just to kind of spread it out some. But you can pick any number that's less than 2. Alright, so I'm going to be replacing my x value with these lovely x's to find my y value. Which, if you want to go ahead and fill in the x value in your coordinate, you can do that. So I have 1x at 2, 1 at 0, and 1 at -2. And we will be solving for our y value. So I'm going to replace all my x's with these lovely numbers. So my first one is going to be -3 times x, which is 2, which equals -6. So my first point is going to be at 2, -6. The next number I'm going to use is 0, so I'm going to plug that bad boy into my equation. So -3 times 0 will give me a 0. Look at that. So my next point is at 0, 0. And my last one, I'm going to replace this x right here with a -2. So -3 times -2 will equal a +6. So my next y value will be a 6. Alright, now before we get these graphs, first of all, we need to kind of know what the shape of the graph is, and I also need to know whether or not my points are open or closed bubbles. So, looking at my inequality, first of all, since this cannot equal an x, since it doesn't have the line underneath it, I know it cannot equal the 2. So when x is 2, this has to be an open bubble. Now, since these values are numbers within the interval, they're not the numbers on the inequality. Remember, those are always closed no matter what. Alright, so now when we're graphing these points, alright, we need to know what the shape of the graph is going to look like. So, looking here, my x is to the first power. Remember, if you don't see an exponent, it secretly is a 1. And anything to the first power will be a linear graph, which is a line. So it's going to be a straight line of some sort. Alright, so let's just get this first one graphed. So we have a point at 2, -6. So 2, -6. 1, 2, 3, 4, 5, 6. Up, and it's open. Make sure that's open bubble. Alright, and these next two are closed bubbles. So I have one at 0, 0, it's going to be closed. And I have one at -2, 6. -2, 6. 1, 2, 3, 4, 5, 6. About there. Alright, my graph's not perfect, so it should be a straight line, but let's see what it looks like. And this one will have an arrow on the end because it does not have an upper bound. So since it doesn't have an upper bound, or I'm sorry, a lower bound in this case, this is the upper bound. Since it does not have a lower bound, we will draw an arrow. So that is what my very first function is going to look like that's graphed. Alright, so now we're going to do the same thing with our second graph. So first of all, let's make sure that it does work out on the right hand side of our line. So these are the values that are greater than or equal to 2. So if we look over here, these are things like 3, 4, 5, etc. And we're heading in the positive x direction. So these are in fact values that are greater than or equal to 2. So this graph is going to fall on this side of our vertical line. Alright, so like before, we're going to pick numbers that are in our interval. So we're going to start with the 2. Always start with the number listed with the inequality. And then we're going to pick values that fall within the interval. So those are things that are larger than 2. So you could pick anything. I don't know, I'll just pick 3 and 5. Why not? Okay, so now we're going to substitute in these bad boys right here for x and solve for y. Which if you want to go ahead and fill in the x values, you can. So my x's are at 2, 3, and 5. Alright, let's get going. So I'm going to replace this x with the 2. So 2 plus 3, which will give me a 5. So my first coordinate will be at 2, 5. Alright, my next one I'm going to replace this x with a 3. So 3 plus a 3 equals a 6. Alright, so my next y value is at a 6. And finally I'm going to replace this x with a 5. So 5 plus 3 gives me an 8. So my last y value will be an 8. Alright, now before we get this graph, we have to decide, is it an open bubble or is it a closed bubble? Dun dun dun. Alright, so let's see. So our first one, at x is 2, it can equal to 2 because it has the line underneath our inequality. So since it can equal it, it will be a closed bubble. Alright, and then since these x values are numbers within the interval, not the number on the inequality, these are always going to be closed, no matter what. Alright, so all of them are going to be closed. So let's see what this one looks like. So we have one at 2, 5. So 2 up, 1, 2, 3, 4, 5. And this one is closed. Alright, my next one is at 3, 6. So 3, 6. And then my next one is at 5, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Alright, so 5, 8 up here. Alright, which I'm just going to white out the 2 so you guys don't get confused with that when I graph. It's my second. Alright, so 5, 8 is way up here. Alright, and since I don't have an upper bound, I have a lower bound. Hey, that means there will be an arrow on this graph. Alright, so that's what this graph looks like. Pretty neat, right? And of course, our graph deserves a name. They always deserve to be named. So the name of this graph is going to be Patsy. Patsy, the piecewise function. Alright, and before we're done, we need to find the domain and the range. Okay, which again, the domain are our x values, and the range are our y values. So the domain, those are our x values, and the range, those are the y values. Alright, which like before, I'm going to show you how to use interval notation or inequality notation. So let's focus on our x values. So those are going to be the values on the x-axis. So I'm going to highlight it in pink so you can kind of get a visual. Alright, so for interval notation, remember you have to pick and choose which one you like. You can't mix them together. So for interval notation, you say how far left will it go? How far right will it go? Alright, so if we look here, how far left, we're looking at the entire function, which I know looks a little strange. So how far left does this thing go? Well, this is going to keep extending off to the left for forever. So all the negative x values are going to be used. And since we are headed in the negative infinity direction where the demon cats hang out, so watch out. Okay, it'll be a parenthesis with a negative infinity. And remember, we can't equal infinity, so we put a parenthesis. Now how far right it goes, if you look at the blue guy right here, it keeps going to the right for forever. So we're headed in the positive x direction for forever. So that'll be positive infinity. So to infinity and beyond with Buzz Lightyear. Okay, and you're probably wondering about this section right here because it looks a little funny. So this is where x is 2. Now in one of the functions it cannot equal 2, but on the other function it can equal 2. So remember, the closed bubble always beats out the open bubble. So even though one of the functions can't have a 2, the other one can. And since we're talking about the entire piecewise function, 2 is still allowed. So even though it looks like 2 can't be counted, it can. So all of our x values work. So from negative infinity to positive infinity. Or if you like inequality notation, remember the way we write this up here, since all the numbers worked, we're going to say x is all real, all the real numbers. So again, the way you write that, you say x, the way you write is, or such that in math, put the little C thing, and put a horizontal line in the middle, kind of looks like a weirdie. And then the all real number symbol, you draw 2 vertical lines, and then just draw an R shape. So you can use either of those for your domain, does not matter. Alright, now the range involves the y values of the function, so we're going to be looking at the y-axis. So we're going to see which values on the y can be used in the entire function. So let's see, if we look here, even though this part right here looks like there's a gap, there's actually not a gap because the pink graph kind of fills in the y values in between these two dots. So we are going to be using the y values that fall in between these 2 points right here because they're filled in right here. Alright, so let's ask yourselves for the range. You always say how low does the graph go or how high does the graph go. So if we say how low does it go on the y, the lowest y we see is at a -6. 1, 2, 3, 4, 5, 6, yes. And here it cannot equal at the -6. So since it cannot equal -6, remember we use a parenthesis when it cannot equal it. And then we ask ourselves, how high does the graph go? Well, both of our graphs have the arrows pointing up, which means they're going to infinity and beyond in the positive x direction. And since we cannot equal infinity, remember we use the parenthesis. So that is what our range would look like in interval notation. So if you want to use interval notation, you have to use both of these. You can't like mix this one with that one, so be careful. Alright, and then the inequality notation, we start with the y. And we have to somehow create this inequality. So I see here, it goes all the way down to -6, and it goes all the way to infinity. So I know a -6 is going to be involved. Alright, I know that it's not going to be equal to because there's an open bubble this time. So these are the numbers up here in the pink and blue graph. These are the numbers that are larger than -6. Because these are things like -3, -2, -1, 4, 5, 6, 7, etc. So since these are the numbers that are larger than -6, we're going to use the greater than symbol. So these are all the y values that are greater than -6, but cannot equal -6 because there's an open bubble. So bam, that is our domain and range right here. So I'll box it. It's always good to box your answers in math. Alright, and this is what our lovely graph looks like. Awesome job, you guys.